morning to everyone. Today we will discuss the topic theolite surveying. So theolite surveying means measurement of horizontal angle and vertical angles. It's a very more preciously and then very accurate measurements. And then already used for a compass measurements, measuring the horizontal angles by using compass with respect to meridian, which is less accurate, and also it's not possible to measure vertical angles with a compass when the object are not considerable distance or situated at a considerable elevation or depression. It becomes necessary to measure horizontal angle and vertical angles more precisely. So these measurements are taken by the instruments is known as theolite. So theolite is a very accurate measurements for the theolite surveying, and then angles are measured with the help of the theolite is also called a theolite surveying. Application of theolite. So theolite is most accurate surveying instrument. The mainly used for it is a measuring for horizontal and vertical angles, locating points on a line, prolonging the survey lines, finding the difference of levels, setting out of grades, ranging curves, tachometric survey. So and then this is theolite and the components. So first one is the vertical axis. The uh, vertical lines is called a vertical axis. This object is objective, and this is one as a telescope. This is a altitude bubble, and then this is a vertical clamping screw. So horizontal axis is called a turning axis. This is a vertical circle, and the last one is a eyepiece. This is a plate level, upper plate, and then vernier A and B, lower plate, inner spindle, outer spindle, tri-patch. This is a leveling screw, tripod, tripod head, and tripod legs. This is components of the theolite. And the major thing of theolite previous measurement used for accurate measurements for horizontal and vertical angles. It is widely used for various purposes and hence called the universal measurements. Theolite are primarily classified as transit theolite and then non-transit theolite. So transit theolite means a telescope can be revolved through a complete revolution about its horizontal axis in a vertical plane. Non-transit theolite means one telescope can be rotated only by a limited amount in the vertical plane. This is called a non-transit theolite. Mostly now we are used for transit theolites. And then next one is components of transit theolite. So transit theolite consists of the following parts: leveling head, second one is lower plate, upper plate, standards, T-frame, plate levels, telescope, altitude bubble, plumper, compass. So first one is leveling head. So what is meant by leveling head? Leveling head is the instrument which houses to parallel plated fitted with 3 or 4 leveling screws. So the leveling screws go through the upper plate, and then they're screwed with the threads on the leveling head and upper plate and the lower plates. Such a provision is made for the leveling instrument. For the suitability of 3 leveling screw are sufficient. So next one is lower plate. This is also called a graduated circle or scale plate. This varies from 0 to 360 degree and is subdivided into 10 to 20 minutes. So provisions is made to clamp the lower plate at any position by use of the lower clamper. Finally, the movement can be made by the using of lower tangent screw. So next one is upper plate. Upper plate is attached to the inner plate. This plate is also called as vernier plate. So upper plate or other name is vernier plate. So next one is the central axis of the inner spindle and coincides with the outer one. This is imaginary axis known as vertical axis. This movement of the plate can be fixed by the upper clamp screw, and this is essential arrangements in the measurement of horizontal angles. Next one is standards. This is safe like the letter of A. It's also called A frame, which is the supporting frame for the telescope. The top of the standards are provided with the bearing for the pivots of the telescope. Next one is T frame. T frame also called as index bar. This is used for front of the vertical circle is provided to the standards, and it's provided with the clip screw at the lower end. At the lower end, the clip screw is used for the adjust the altitude bubble. And the next one is plate level. Plate level is fixed on the upper plate, which has to be centered with the help of the leveling screw. Next one is telescope. Internally focusing telescope is fixed usually in the theodolite. The telescope is supported on the pivot of the turn axis is the explained here. And then altitude bubble. So long sensitive bubble tube is called the altitude. Is fixed on the index bar. A mirror is provided to view the bubble when the instrument height is moved, and then plump up is exactly over the station center of the theodolite. In order to center the theodolite exactly over the station, it's called plump up. This is suspended from the hook fitted to the bottom of the central vertical axis. Next one is compass. Compass, a circular box compass is fitted on a vertical scale between the standard in same instrument. The compass is provided in order to take the magnetic bearing of the line. Next is uses of theodolite. The following some purpose of the for the theodolite can be used. First one is measurement of horizontal angles. Second one is measurement of vertical angles. Third one is measurement of deflection angles in curves. Next one is locating points on the existing line. Next one is determining the difference in elevation. Next one is establishing grades. Next one is measuring horizontal distance between 2 points. Finding the vertical height of the object, measuring the magnetic bearing using the compass fitted in. So this is also known as use of theodolites, and many terms of the terminologies of the theodolite. So first one is centering, transisting, phase left, phase right, telescope normal, telescope inverted, changing phase, swinging the telescope, vertical axis, horizontal axis, line of collimation, the axis of a telescope, axis of bubble tube, least count of the vernier, diaphragm. So the major terms explained in this session. So line of collimation, first one is, it is also called as line of sight, which is on imaginary line. The passing through the intersection of the crosshair are the diaphragm and the center of the object class. So next one is least count of the vernier. So it is smallest value that can be measured by the theodolite. This is generally of 20 seconds. Next one is diaphragm. Diaphragm means it is the brace ring provided with the glass disc with fine lines. It is provided with a crosshair. It is fixed in front of the eyepiece. The crosshair may be fine platinum wire or made of spider web. So next one is centering, transisting, facelift, face right. So centering means the planing a theolite fitted on a tripod exactly over the station points means plump off is known as centering. Transisting. It is a process of turning the telescope about the turning axis of the vertical plane through the 180-degree. Next one is facelift. The vertical circle of the theolite is on left on the observer of the time of the observation is called facelift. So vertical circle of the theolite is on the right of the observer at the time of observation is called face right. This is the term of main term of the theolite. Next one is reading in vernier theolite. So least count of the vernier has to be decided first. Generally, the least count is 20 seconds. The main division of the main scale is 1 degree. It is to be divided into 3 parts. Then each part is 20 minutes. So least count is calculated for d divided by small n. D means 20 minutes divided by n means 60 into 60 equal to 20 seconds. So least count for one small divisions 20 seconds. Least count for one big divisions 20 seconds it 3 terms. So 60 seconds. 60 seconds means 1 minute. This is the reading of vernier theolite. Next one is temporary adjustments of theolite. So next one is temporary adjustments of the theolite. So the adjustments of the theolite are of two kinds. First one is permanent theolite adjustments. Second one is temporary adjustments. Temporary adjustments. Permanent adjustments are made of establish the relationship between the fundamental lines of theolite, and once made, they last for a long time. They are essential for the accuracy of observations. So first one is adjustments of horizontal plate levels. Second one is collimations of adjustments. Third one is horizontal axis adjustments. Adjustments of telescope level or the altitude level plate levels. The vertical circle index adjustments. Next one is temporary adjustments. Temporary adjustments are made at each setup of the instrument. Before we start taking the observations with the instrument, there are 3 temporary adjustments of the theolite. So first one is centering, leveling, focusing. So temporary adjustments of the theolite require to be made at every set of the instrument. Permanent adjustments are required to be established the fixed relationship between the fundamental axis of the theolite and also necessary for accurate results. So first one temporary adjustments, setting out of the over the station, leveling by tripod stand, centering, leveling and focusing. Focusing of the eyepiece, eliminating of parallax, setting the vernier. So setting over the station, the tripod stand is placed approximately over the station, such the center of the tripod is just in the line with the center of the station. Then the theolite is lifted from the box fixed in the top of the tripod sticks. Next one is tripod stand leveling. The leg of the tripod stand are spread well apart and to be fixed firmly on the ground. Approximate leveling is done by the stand itself. In order to this, 2 legs are kept firmly fixed. The third one is moved such that the bubble remains the center of the run. And then centering. That's a process of which is the instrument is set out exactly over the station point. At the time of leveling by leg adjustments itself, the correct centering should be done by suspending the plumb bob. Next one is leveling. Uh, Before the starting of the leveling operation, it should be ensured that the foot screw are brought to be the center of the run. The first position the plate bubble is placed parallel to any pair of the foot screw 1 and 2. The bubble is brought to be the center. It's run by this two foot screw equally inward or outwards. Next one. Now the second position the plate bubble is turned through the 90-degree such that the perpendicular to the line joining to foot screw 1 and 2. The bubble is brought to center of the run by running by running the telescope of the third foot screw either the clockwise or anti-clockwise. The procedure of is repeated such that the bubble is remains the center of this run. This position, the plate bubble tube is rotated 360-degree about the vertical axis. This also the bubble should be center of its run. Focusing the eyepiece. Focusing is the done by adjusting the eyepiece for to get the clear view of the crosshair. This is done by directing the telescope to the sky or pieces of the whitest white one is held in front of the object glass and the eyepiece is moved in or out such as that the crosshair appear clear and soft. Next one, eliminating the parallax. This is done to get the sharp image of the object or target on the plane crosshair and to eliminate the parallax. The telescope is directed towards the object and the focusing is done. The image of the appears. Next one is permanent adjustment of the theodolite. The following relationship between the fundamental lines should be fulfilled by a transit theodolite, which is a perfect adjustment. So first one is adjustments of plate levels. Axis of bubble tube should be perpendicular to the vertical axis. Second one, line of collimation should be perpendicular to the horizontal axis or turning axis. Third one, horizontal axis should be perpendicular to the vertical axis. Fourth one, axis of the telescope level should be parallel to the line of collimation. Fifth one, the vernier should be read 0 when the instrument is leveled. The above relationship should be obtained in order to be the adjustments of the should be performed accordingly. So this is the permanent adjustments of the theodolite. And then the next topic is measuring the horizontal angles. There are three methods of measuring the horizontal angles. First one, ordinary method. Second one, repetition method. Third one, reiteration method. So generally, first one is ordinary method. The procedure of the general procedure of ordinary methods. First, at an angle AOB is to be measured. The theodolite is set up. The theodolite is set up over the station O. First, all the temporary adjustments are made. Next, the first observation taken with the facelift. The lower clamp is tightened and the upper clamp is loosened. So next one is telescope is turned clockwise such that vernier A is set to 0 degree. Vernier B is approximately 180 degree. The upper clamp is tightened. The operating the tangent screw vernier A and B are set exactly 0 degree and 180 degree respectively. The lower clamp is then loosened and then telescope is directly the object A is located at the left. The ranging rod is A is bisected roughly. The lower clamp is tightened and by the operating the tangent screw, ranging rod is A is accurately bisected. Keeping the lower clamp at fixed conditions, the upper clamp is loosened. The telescope is turned clockwise is roughly located the ranging rod at the P. Upper clamp is fixed and the tangent screw is operated to get correct the bisected ranging rod at B. The reading on vernier A angle is noted directly. In case of vernier B, the angle is obtained by subtracting the initial reading from the final reading. Next, the reading are tabulated. So next one is the base is changed to right and above procedure is repeated. And the reading on both the verniers are noted. Next one is the average of face left and face right observation is the actual horizontal angle AOB. Next, last point is face left and face right observation eliminated any possible error due to imperfect adjustments of the instruments. This is called ordinary methods. Next one is repetition method. This method of repetition of measuring horizontal angles used for very accurate work. So this is the following procedure of the repetition. So first point is instrument is set over the station O and the temporary adjustments are made. The telescope should be in the normal position and the face should be left. Next one is vernier is set to 60 degree. The lower clamp is loosened and the telescope is directed towards. The left hand station A and bisected using lower clamp and tangent screw. The vernier reading is at A and B once again checked for the initial reading. The readings are taken 360 degree and 180 degree. So next one is upper clamp is unclamped and the telescope turned clockwise and the right hand station B is bisected exactly using the upper clamp and the upper tangent screw. So both the verniers are to note the approximate value of the angle, say 50 degree, 2 minutes 20 seconds. Keeping the verniers unchanged. Unclamp the lower plate, turn the axis of the clockwise direction. The object A is bisected using the lower clamp and a tangent screw. So the process is repeated usually 3 until record the repetition is over. So the final reading should be N into 58 degree, 2 minutes 20 seconds. N is the number of repetition to the final reading. 360 degree is added for every revolution and divided by the number of repetition to get the final value of AOB, angle AOB. The average of the two values of the angles gives the previous value of AOB, angle AOB. This is the final procedure of the repetition methods. And then errors eliminated by these methods due to eccentricity of the center on the vernier are eliminated. Due to imperfect adjustments of the line of collimation, axis of the telescope are eliminated. graduations are minimized, and pointing tended to compensate each other, or the other errors minimized by the divisions. So next method is reiteration methods. Reiteration methods is a high precision method, and then the method is tedious and mostly preferred when several angles are to be measured from the single station. The following methods reiteration. First one is measurement is set on O. Initial adjustments are made accurately. The vernier is set to 0. Next, the telescope is directly any distant object P to the lefty extremes object, bisected accurately using the lower clamp and the lower tangent screw. The vernier reading is noted. So next point is next step is upper plate is loosened and telescope is turned clockwise, and the telescope of the object B is bisected accurately. Similarly, the object C and D bisected successfully and reading both the vernier every bisection. So finally, the horizon is closed by citing the reference object P or the first point A. Now the vernier A should read 360 degree. If not, the error is noted and distributed equally if the error is small. Otherwise, the process is repeated. So the vernier is A is set to 60 degree or 90 degree. The horizontal angles are measured in the same manner. This time, the telescope is turned in anti-clockwise direction. This operation is done to compensate for slip. Under errors due to twisting of instrument, both the vernier are read at every bisections. And then other procedure is same as done for the face left observation. The mean of the two result of the taken, the exact value of repetition methods. This is the procedure of reiteration methods. Next one is measurement of vertical angle. The vertical angle is an angle between inclined the line of sight and the horizontal. It may an angle of elevation or depression according as the object is above or below the horizontal plane. This following procedure for to measure the vertical angle of object A from the station O. Next, to measure the vertical angles between the points A and B. So first the procedure is first step is instrument is set the station of O and accurately leveled. The instrument is set the station O and accurately leveled. So the station, the object is A is bisected as explained in the previous procedure, and the readings noted theta1. Similarly, object B is bisected and the angle recorded theta2. The difference between the reading theta1 minus theta2 gives the value of vertical angles. If the points of A and B are same side, above or below the horizontal plane, the sum of the readings theta1 plus theta2 will give the values of vertical angles. If the points A and B are on either side of the horizontal plane. In case of base left and base right observation are noted the values of taken to the vertical angles. So this means of vertical angles measurements. So next topic is contouring. Next topic is contouring. So contour means a contour line may be defined as an imaginary line passing through the points of equal reduced levels. A contour lines may also be defined as the intersection of the level surface to the surface of the earth. So examples, the contour of 90 meter indicates that all of the points line have the RL of 90 meter. Similarly, the contour of 89 meter, all the points have 89 meter. This is called the contour and contour lines. So next one is contour interval. The vertical distance between two consecutive contour is also known as contour interval. So examples, a map indicates the contour lines 90 meter, 89 meter, 88 meter, as well, and so on, etc. So the contour interval is 1 meter. The intervals depends upon the nature of the ground, flat or steep, and then scale of the map, the purpose of the survey, and then flat ground are generally small. Example, 0.04 meter, 0.5 meter, 0.75 meter. Steep slope is hilly areas is generally greater, 5 meter, 10 meter, 15 meter, exactly. Small scale map interval may be 1 meter, 2 meter, 3 meter. So this is a desirable constant contour interval for particular maps. It is called contour intervals. So this is also called as contour and a contour interval. Today's session is cover the topic of theodolite and contours. So any queries? Any queries? Okay. So understand the all of the procedures, and thank you.